Well, hello, all of you who are there. I can't see you at the moment, but I will once we switch to a different view. Good afternoon and welcome to this forum. And we're addressing the question of whether off-site manufacturing is the panacea for construction error. I've had some experience in this field, so I'll hopefully be able to make an effective contribution. Consultants have an even greater role to play in the off-site construction sphere because of the earlier decisions that need to be made. So it's good that we are going to hear today from Tom Osborne of Knight Architects. Please join in as much as you can and contribute to the discussions in the breakout rooms. I'm going to run through a brief introduction to GIRI for those of you who are not familiar with us, and apologies to our seasoned GIRI Forum veterans, and then hand over to Nick to lead the session. On the housekeeping front, can I ask you to mute your microphones if you're not speaking, but remember to turn them back on when you're in the breakout rooms. If you don't mind, please leave on your video because that way we feel the meeting has more vitality. Any questions as we go through, use the chat box and Nick or I will pick up on those at the end or get back to you after the meeting. If you have any tech problems, the usual tech advice, switch off and try again, i.e. leave the meeting and then rejoin using the same link. Many of you are familiar with GIRI to a greater or lesser extent, but I think it's worth reflecting on some key points about our origins and key messaging. The original research into the cost of error was carried out and led to the publication of our strategy for change, which is with the objective of generating a significant change in the efficiency of the UK construction industry by reducing the amount of errors made. We carried out this research in 2016 and it was jointly funded by industry and the CITB. The results showed how much waste was caused by error, 21% of GDP. 5% on direct cost of error, which I think we would all understand. Then there's 7% on the indirect cost of error, which is resources that are impacted by that direct cost. The unrecorded process waste, slightly more difficult to understand, but it's errors that occur. They're identified, corrected, but not properly recorded. And then there's latent defects, which we're unfortunately familiar with, which remain in place after buildings or infrastructure have been handed over. The research identified the top 10 root causes of error, and Nick will be coming to this again later. Our activities following the result of this research have been targeted on these higher ranking causes: planning, design, culture, communication, commercial pressures, and supervisory skills. Originally, we secured the funding to carry out the research project, and we set up GIRI with these 5 key aims. To create a culture and working environment to get things right, to change attitudes and leadership, to engage all stakeholders, to share knowledge, and to improve skills. Originally, we started with 14 companies, and that was in 2017, and we now have over 60 members. Let's take a quick look at how GIRI is going about seeking to achieve its objectives of error reduction and the many benefits that such an approach brings. First, we have thought leadership. This is we provide this through our training courses. We have leadership training, interface management training, and supervisory training. These courses are all CITB accredited, so you can get your grant if you pay your levy. We have campaigns, webinars, audiences in USA and Australia. There's the supply chain e-learning school and the ICE Learning Hub with whom we have a relationship, and we do many seminars and workshops. And then we have our forums. As many of you will know, we've been running a number of forums such as today during the COVID lockdown, and we've covered many subjects such as diversity, culture, carbon and climate change, construction insurance risk, and design information sources. And the other part of GIRI is looking at knowledge sharing. We've got many technology and other research projects we've carried out, and the results are on our website, along with our design guide. Design features frequently in the list, so we produced a guide to increasing value by reducing the error in design. We have social media and networking. As far as social media is concerned, we've continually increased our activity in this area, and our website and regular newsletters stand to show this, and we're active on LinkedIn, Facebook and Twitter. On networking, this has been a bit hampered by COVID, but we're having a members meeting on the 1st of July, and we're going to trial some virtual networking. So if you're a member, please come along. So what are the gains that we get from our error-free approach? Well, there's the productivity gains, saving time and money. Safety, well, there's been a study in Australia that 37% of accidents occur during rework. So if we can avoid making error, we're providing a safer product. Sustainability, well, the avoiding waste reduces our carbon footprint. The quality benefits are obviously manifest. Correcting error takes time and money, so if we avoid it, our outturns in terms of price and completion will be more predictable. And the overall effect is that we'll have better reputation, both for individual companies and for construction as a whole. So our strategic aim is to improve in construction productivity and quality and reduce costs and waste by eliminating error. As I mentioned, our next meeting is on the members meeting is on the 1st of July, which we're holding online due to continuing restrictions. So we need to have the right culture for throughout the industry. And we need to change the way we work and behave now. So let's hear from Nick. Thanks.
Brilliant. Thank you very much, Cliff. Right, can we see everybody? Could you just stop? There we go. Great. So if you possibly can you please turn your cameras on and give me a wave? And it just gives me that warm, fuzzy feeling that there are other human beings I'm talking to. I'm not just going insane sitting in my attic for the last year and a half. Great. Really good to see you all. Now, we've got a really interesting session lined up this afternoon. And as it says on the tin, we're looking at off-site manufacturing to see if this is the panacea for avoiding construction error. But what we're going to do is we're not just thinking about off-site manufacture, we're actually including things like modular construction and modern methods of construction. So really you can think of this about anywhere that we're taking physical work and complexity away from the building site and doing it beforehand elsewhere. So that's really what we're talking about. Now I will share my screen. Here we go. That one. Share. Now, this is a mural board, so it's basically just a big whiteboard that we're going to use for this afternoon's session. And we're going to try and answer a number of questions. To start off, we're going to come over here and we're going to just capture what experience have we got in the room, because we've got somewhere well over 40 people on the call, and I anticipate that between us, we've probably got quite a lot of experience. So let's expose that right up front so that we can see what expertise we can draw on within our group. We're then very lucky because we've got Tom from Knight Architects with us, who's going to give us a case study of their very exciting new bridge. Clearly, a lot of us, when we think about modular, we think about buildings, but we're going to hear about much more the infrastructure side of things from Tom. And then we're going to move on and focus on error. So we'll start off by looking at what do GIRI know are the root causes of error. And then we're going to ask a slight question on that and say, well, actually, of those known root causes of error, how are they affected if we adopt modern methods of construction? So all of our research where we are at the moment is largely based on traditional construction. So we need to sort of take the lid off that and go, well, okay, so how does this change? Then we're going to have a look at the project life cycle and sort of zoom in a bit and say, well, if we think about a project life cycle, do the models that we use still apply for modern methods of construction? So we'll sort of open the can on that as well. And then what we'll do is we'll have a sort of dive into interfaces. Now, we know that interfaces are a major challenge in construction, and so we'll use our interfaces triangle, which I'll explain shortly. And we will then have some breakout groups where you'll be put into separate groups. I think we'll probably use just 6 groups today because of the number of people we've got. And in your groups, you will try and answer a question, which is just, what are the new interfaces? So it's that what's changed type question. And we'll explore what you come up with in your groups. And then what we'll do is say, okay, well, so what? If we've spotted that there are new interfaces, what does that mean in terms of error? How can that help us understand where the new sorts of error might be coming from? And then we'll finish off with some more breakout groups and basically do the really big so what at the end and say, well, if we know that this is where the errors are going to be coming from, what should we be doing about it? Where are our priorities as an industry to stop these errors from happening? Because that's what GIRI is all about. So what I'm going to do now is invite you all into this mural board. So this is basically just a big whiteboard, and you will be able to move around it. If you've got a scrolly mouse like this, you can zoom in and out by moving your mouse up and down, or you can use the little thing at the bottom right of the screen. So that's like you would get on any AutoCAD type of display, and that shows you which bit you're looking at. And you can use that slider there to slide yourself zoom in and out. So you can just grab it. And what I want you to do, please, is when you come in, I'll share a link in a moment. I'd like you to come over to this first bit here, where it says our experience, and just zoom into this box. And what I'd like you all to do, please, is first of all, just put your name on a sticky note so we can see who's here. And I'll show you how to do that. You look for that little emblem that looks like a sticky note over on the left of the screen, click on that, grab yourself a sticky note and drag it onto the screen where you want it and type your name. So I'll type Nick. Oh, not Vic. It's failed at the first hurdle there. There we go, Nick. And the next thing I want you to do is, if you have any knowledge at all of any project that has involved off-site manufacture, grab another sticky note and just put the name of it there. So I'm going to talk about Berkeley Kidbrooke. So that's a project that Get It Right Initiative have been helping with, and that's a large project that's using modular construction. Now, the really clever bit is, our next thing I want you to do is to bring a picture of that project in. So if you look for the icon that looks like a mountain with a sun, so that's over on the left of the screen again, mountain with sun images. And any image that's on the internet, if you type in a word, it should pop up. So I'm going to say Berkeley Kidbrooke modular. There we go, and that'll do. Okay. There's an image. I'll make it smaller because otherwise it'll fill up the screen completely. So I have now put my name, the name of a project, and the an image of that project on the screen. If you've got time, you can try linking them up with arrows, but that's advanced. That's for the experts on mural. So what I'm going to do now is I'm going to invite you all into this mural. So the way I'm going to do that is I will share a link in the chat box. If you just click on the link, a new window will open up. It will ask you to type in your name or any name you want, and then you'll be invited and you will appear in this mural. So I'll do that now. So I'll click share, visit a link, copy link, and then I will put that in the chat box. There we go. Okay, so that should now be in the chat box. And if you're on a mobile phone, this might not work. Please just stick with it. What I'll do is I'll share the screen whilst everyone starts appearing in here. And if you aren't able to access the mural board, don't worry, you'll still participate fully in the session. But if you are able to, it just means you can stick your own Post-it notes up and it'll just add us the way we collaborate. So I will grab you all now, so you're all looking at the correct bit of the screen. There we go, summon. And what I'll do is I will turn this timer on for, say, 2 minutes to let people start putting up their pictures. And I'll leave this running on the screen, so if you're not in Mural, you can see what everyone else is doing. And I will stop talking whilst you do that. If you've got questions, please just shout out, and that way I can help you if you have any issues. Chances are someone else will be having the same. Brilliant. Right. Well, that's the little pinger, our airport alarm, to tell us that we've had 2 minutes. So what I'd like to do, please, I will continue sharing my screen so that anyone who's not in Mural can have a look. What I'm going to do is ask a couple of people if they can just comment on what they have put. So we've got a lovely image up here. This is well, you can see what it is. It looks like timber houses with balconies. Whose project is this one? And ask you just to unmute and just explain what this project is. If you're able to, please. Having a silence there. All right, we'll move on to the next one. We've got Kevin Morrissey. You've talking about St Helens Hospital. Maybe you could just expand. How was modular used on that, please?
So it was used extensively to address M&E trade, construction delivery issues, and resource utilisation. So pretty much any vertical or horizontal distribution of M&E services through that that facility was delivered as a prefabricated modular assembly. So the program was significantly improved from what it would have been. Resource was managed more effectively as well. So and there was also plant room areas, and but it was used significantly across that project.
Interesting. Okay, something that I'd not really thought of there. That for MEP, it's the modular is a really significant thing. Great.
Yeah.
Thank you. And I noticed interestingly as well, we've got Tideway down here. Victoria, you mentioned about Tideway. Could you just explain how modular comes in there, please?
Hello. Yeah. So I was just trying to find the unmute. I'm not used to using WebEx.
Yeah, always a challenge.
Yeah, so they used so reinforcement prefab basically for optimized delivery performance. So we were fixing reinforcement with a shaft environment which is 60 meters below ground level, basically hazardous. high levels of repetitive manhandling, obviously increased exposure to risk within that shaft working. So the reinforcement prefab they did was basically in an off-site facility, and then they delivered the prefabbed sections to site by either road or by barge as well, obviously, because it's Thames Tideway, which significantly reduced the need to install the reinforcement in situ within the shaft. So the realised benefits we've captured from that is at least a 65% of the reinforcement that was fixed, and the quality insurance checked in the factory conditions meant that it was then shifted off the project critical path. So a really good realised benefit, and they reckon around a 60% reduction in installation time compared to in situ fixing. So that's pretty good.
Really interesting. Okay, and it's fascinating there that you talked about how it shifts things off the critical path. So I think that's probably something we'll come back to is where is your critical path when you're using a modern method of construction. Very interesting. Thank you. Okay, what I'll ask you all to do now, please, is if you can just minimise the window that you've got mural in. So the I think top right of your screen, the little straight line, and your mural window will minimise. And what I'll do now is I've got the great pleasure to hand over to Tom Osborne, who's going to give us an overview of a bridge that Knight Architects have been intimately involved with designing.
Thanks,
So,
Nick. Hello, everyone. Thank you for having me today. Don't know the famous words we're sick of hearing. Can everyone see my screen?
Yeah, that's great.
Yes, we get it. Cool. So I just wanted to spend 10 minutes talking to you a little bit about our recent bridge for Network Rail called the Flow Bridge. For those of you who don't know, we're Knight Architects. We only design bridges and infrastructure projects. Buildings are far too challenging, and so we stick with bridges, which is nice and simple. And in many ways, bridges are all off-site. There aren't very many bridges today that are built on-site, so we kind of sometimes don't fully appreciate that this is an off-site manufacture setup. And I just wanted to talk to you through some of the challenges of this bridge, because I think it's a unique bridge in its form, but also in the way it was procured. It's a very large team led by Network Rail, but with a host of others, and the team makeup I'll come back to a little bit later, because I think that's part of what made this quite a special project. Essentially, we were working together almost from the outset. The problem for us was very clear, but it was an important part of the process, really everyone understanding the problem. So level crossings are dangerous. Network Rail have a mission to replace them with safer crossings of the railway. Translating that into a design brief was one of our challenges, that we had a lot of key performance enablers or criteria which we used to assess whether we were on the right track. And really our aim was to produce something that could be delivered in a reduced construction time, that was adaptable and modular, so not just a one-off bridge, but a system that could be rolled out across the network, and critically that used composites. And really we wanted to do this not to sort of replicate bridges that have been done in the past, but to see what could be done with this new material. So why composites? It's lightweight, it's cost effective, it's strong, and it gives us quite a lot of freedom in design that steel and concrete often don't. But really, rather than rushing to think about the object, which is often whenever anyone sets up to do modular or offsite, I think sometimes they rush to think about the built product, or how to build it, how to solve this, the sort of fabric of the solution. But we were quite keen that the design started with an exploration of the user experience. Often this is the user experience for railway bridges: quite dark, sharp corners, really poor visibility of your onward route, and relatively unappealing crossings. This is my home station in High Wycombe. More rurally, you tend to get these bathtub bridges which block views, and really railway bridges should be a moment on a walk that is has a lovely view, and that seems to have been not the case for some time. So our module, our system really wanted to address this corner. We wanted to stop it being 90 degrees and turn it to a smooth corner. if you do that, you tend to make the solution longer, the crossing longer, because it pushes the supports out away from the railway. And so what we ended up doing was creating a separate spine, which allowed the supports to remain orthogonal to the railway, whilst the deck kind of curved away from them. And so we have the sort of key design of our bridge. We then wanted to make it fast to install, and this was a lot of what the time was spent doing, is working out how this spine could be used almost as temporary, permanent formwork, I beg your pardon. So these deck modules, using the flexibility of the material to clamp on with this gravity clamp system, allowing them to be installed and also removed very easily across the railway. But making sure that the user experience was retained throughout, with good visibility, and using glazing on top of the FRP to provide an open user experience for what is quite a tight, narrow deck. So the construction sequence, essentially, you put the spine up first. We used some temporary supports this time. Hopefully you will be able to remove those next time. And then you apply the deck modules to that. And you end up with a structural spine that is kind of working as an arch. I get out of my depth here a little bit, but it's basically working as a series of arches with a deck on top. And so this was the sort of base design. And I think one of the key lessons from my side is that we work an awful lot on design and build processes where the design, we'll come up with the same design in a similar amount of time, but then that design has to go through a series of hurdles before it's ultimately built, and maybe even before the fabricators or people that really understand the material have seen it. And then we end up chasing our tail trying to retain the qualities of the original design whilst it becomes buildable and practical and so on. But here this design was established quite quickly, and the team was already in place. So the design was iterated, I suppose, is the right way of saying it, slowly and in an informed way by the whole team, rather than being sort of chopped up into packages of work and delivered by separate people. So it wasn't just one thing we were trying to create. We were trying to create an adaptable solution. I'll rush over this because I want to talk more about the process, but it can do different spans. It can do different geometric arrangements. This prototype we were doing has just stairs, but ramps and lift solutions are on their way. And also it's designed to suit different characters of site, so different colors and textures, and different systems to suit levels of vandalism on the site, for example. Asymmetric alignments like this as well. The SCurve was used for the prototype because we could reuse all the molds for one side and just rotate it and redo the mold. So we saved quite a lot of money for the prototype there. The U-shape relied on mirrored molds. But really, in terms of lessons learned, it was the process rather than the product that I think is useful. This is my clumsy way of trying to explain it and how it is in my head. Often our design input, the designers, if you like, in blue, a lot of design time happens here with relatively small amounts of overlap between the contractor or the fabricators, and then their design time or their input happens later with relatively low amounts of our input, and something gets lost in those gaps. I think this is the best explanation I can come up with how it happened here. Is perhaps a little bit earlier. The contractor was involved, investing more design time in the early stages, so that less design overall had to happen in the late stages of design. And when design was happening, we were all doing it together. So this was the prototype, and again, another key message I say would be that the prototype and testing is absolutely fundamental to a smooth process, and we think we know an awful lot about how things will go together, but really 50% or more was learned here when we first started trying. And so really investing in testing the system became essential, and so the prototype being a full bridge is quite unusual, but I think really valuable. Sui Generis is one of the fabricators here who designed the deck units, quite a handmade deck, lots of handmade layups of the fiberglass. You can see here the gravity clamp system being sort of trialed, and it sort of came out of their factory in pieces. I should say at this point, when this photograph was taken, I hadn't met anyone in the design team in person. And this design was done throughout COVID and entirely remotely, which meant a lot of meetings like this, a lot of canvases, just like the one we were just putting Post-it notes on. But it did mean that everybody was in all of the meetings, and design issues were discussed in the round, and everybody was aware of the big challenges. Things started to appear on site. This is the spine designed, fabricated by KS Composites, who use a slightly more mechanical it's a very 3D automated process of CNCing parts here, the carbon fiber heel, and it arrived on site and started to be landed. Some challenges, I would say, are in interfaces. We would say we had a digital model of this spine that was basically perfect. It was put together very, very accurately. One of the main challenges, I think, was the interface with the ground and the exactness of the FRP process relative, and this spine relative to the exactness that could be achieved with the groundworks was one challenge. This uses concrete-free foundations, which we're very pleased to have no concrete on this bridge. But one takeaway is that the sort of the FRP bit is relatively well known digitally. Its translation into the physical world and touching the ground is less known, and therefore a sort of variable. Also, the interface, I would say, with so sorry, there you can see the top of the concrete-free foundations, and then these bolts being very tight tolerances there. Another key interface is with other products. So here we were using glazing, and the interface between the glazing and the FRP is another big challenge. This glazing was one of the things we really wanted to hold on to maintain the openness of the views and the high quality. It won't be appropriate for every single solution, so we've been looking at alternatives with a composite lattice to provide a more robust glazed solution for certain circumstances. But yeah, there we have it. I suppose an off-site modular system where we've only at prototype stage, but we got there in about 10 months, 11 months. We did it by all working together from a very early stage, working very closely with the engineers. Ahmed was the Network Rails in-house engineering team, and actually we had a Cat3 checker that was an expert in FRP that was there along the entire process. So some of those hurdles that you would normally cross later in the stage were de-risked by having involvement at throughout the process. And then testing. We managed to achieve an awful lot of learning through the delivery of this prototype in a relatively sort of sandboxed environment. This is Long Marston Network Rails test site, and that allowed us to be a bit more adventurous in terms of what we were trying to achieve, because it wasn't going to be delivered over a sort of a closure of 6 hours, and it had to be right immediately. So I suppose in terms of our key takeaway of getting it right is recognizing that you won't straight away, but allowing enough, allowing your process to evolve as lessons come to light. That's the original render versus the reality. So I think we actually got quite close. I think that will probably do it for me. That's about 10 minutes, if not a little bit more. So sorry, Nick. I'll shut up.
I think that was absolutely fascinating. So thank you, Tom. That was, I mean, I found that absolutely inspiring. Really interesting as well to hear you start to explore what the differences were for you in terms of your program, in terms of where your effort went, in terms of time, when you're looking at that modular construction. So what I think is really useful for us now is using that, you know, fascinating case study, but to actually start thinking about error. You know, that's why we're here. How can we make our projects work successfully without errors? So can I share my screen? Yes, I have the power to share my screen again. So I'll share my screen. So the Get It Right initiative has done a lot of research to understand error and why errors happen, what the impact of error and why they happen. And this spider diagram, this graph here, is taken directly from the research report, the sort of fundamental research report by the Get It Right initiative. And you can see around the outside a whole list of root causes of error, things that are the root cause of errors in construction projects. And the different lines, the different colours represent different sectors. So you've got blue for civil engineering, red for buildings, and green is the average across the whole of the industry. And the numbers represent relative importance. So 9 is what pops out at the top of the list, and then it drops all the way down. And so you can see that we've got inadequate planning pops out as the most significant, slightly behind that, late design changes, slightly behind that, poorly communicated design information. And you can see that the top 10 of those are broadly similar, but there are an identified top 10 root causes for error within the construction industry. But this research was based primarily on traditional projects and traditional methods of construction. So what I think is really important for us is to start considering, do these root causes still apply, and do they apply in the same way when we are thinking about modern methods of construction? And if they're different, well, in what way are they different? Because we need to know that, because we need to do something about the root causes of error. So what I'm going to ask you to do, please, is if you can all just go back into Mural. So those of you who are using Mural, if you click back on that screen, and what I'd like you to do is just take a minute to think, look at those different root causes. So I will summon you all. Here we go, summon. So you're all looking at the right bit of the screen. There we go. Is everyone looking at the right place? Yeah, I think so. Just have a think about, how are those root causes affected by a change to modern methods of construction and off-site manufacture? And in a moment, I'm going to get you to vote on those things. So I will set up the voting session whilst you have a think about how they may be affected. So here we go. So I will summon you all. There you go, summon. And I'm going to start a voting session. Now, how most affected. Now, what I'm going to do is give everybody 10 votes. And you are looking at a list, basically, I'll share the screen as well. On the screen are 10 different, here we go, share screen. Sorry, my brain can't keep up with my mouth at the moment. There we go, share screen. So there is a list of 10 root causes of error there. And what I'd like you to do, please, you've got 10 votes, and just allocate your votes to the root causes of error that you think are most affected by adopting modular construction. So you could choose to give all of your votes to one of them. You could choose to give 5 votes to one and 4 votes to another, or 1 to each. It's completely up to you, but it's just for us to start to get a feel for how are the root causes of error impacted and affected by adopting modular construction. I'll just give 1 more minute for people to finish voting. Okay, we've got the last few seconds, so 10 seconds left. If you've still got any votes, please put them where you want. Okay, I'm going to end the voting session. So let's see what we think are the main things that are affected. Okay, so we've got 30 votes, a clear winner for time and commercial pressures. So there is a clear perception that time and commercial pressures are going to be hugely impacted by a shift to modern methods of construction. And then at 20 votes each, we've got inadequate attention paid in design to construction, so buildability, and inadequate planning. So we still think that that is a major issue. We've got late design changes, interesting, poor communication, and then we've got 15 votes for poorly coordinated and incorrect design information and poor interface management, and then poorly communicated design information and poor relation in culture to quality down at number 11. So let's see what that looks like on our table. There we go. Okay, so you can see those blobs on the screen. The numbers show just from that quick poll how you think these different root causes of error are going to be affected by adopting modular construction. Now, can I ask someone who voted on this time and commercial pressure, maybe if we use our hands, sticking our hands up, I will stop sharing my screen and we can use the functions in WebEx. Down at the bottom of your screen, there's a thing that says reactions. If you click on that, you can raise your hand. Can anyone who voted for time and commercial pressures, please just put their hand up if they want to explain how is that affected by modular and offsite? Let's see if we've got Simon. I can see your hand is up. Can you come to you, please?
Yes. Hello. Sorry. Can you hear me?
Yeah.
Yeah. So I think the thing about that is something I think we've come across is often how the project's going to be procured really impacts the ability to go to the supply chain and get all that sort of preparatory knowledge that the suppliers might have and bring them into the design team early, because there's a bit of a perception that maybe clients want to commoditize the design so they can go to a range of suppliers, get best price, make it competitive, that sort of stuff. Whereas I think you lose the real knowledge early when it makes a difference, if that's the kind of the expectation. So there's always, I feel, that tension with clients that they want the quality, the time saving, the clever ideas, innovation, whatever, but there's always a pressure on them, particularly public sector clients, to have that kind of visible, we've gone to a bunch of people, we've got the cheapest price, we can prove it. And to me, they're actually contradictory.
Really interesting. Tom, maybe can I ask you to reflect on that?
Yeah, I would just agree, really. I would say often, particularly with the bigger clients, it seems like their commercial processes are set up to incentivize sort of price and de-risk the end result. But I was delighted to work on Flow, where a guy called Andy Cross at NoRL sort of spearheaded quite a different process where investment in the team was done first, making sure that all the skill was there, and then really making sure throughout that that team, kind of putting a lot of faith in the team really to get the product right. So I think it didn't quite gel with NoRL's own usual way of doing things, but I think it's been seen as a bit of a step change, and so I hope more models like that are taken up.
Brilliant. Thanks. Saeed, I can see your hands up. Oh, you're muted.
Yes, thank you. Good afternoon, everyone. Thank you for your efforts. I just would like to ask Tom a quick question, please, regarding the concrete 100%, the unusing of concrete. You are excluding the foundation, right? And the bridges.
No, that is including the foundation. It used
Because you
quite a,
mentioned that it's 100% without concrete usage in your slide.
I did, yes, that's correct, and that is including the foundations, no concrete in the foundations. It
Oh,
uses a
all right.
system called rapid root, which
Wow.
are sort of micro piles driven into the soil. So yeah, absolutely 100%.
That's really fascinating. Thank you for your efforts. Great job. Thank you.
Brilliant, thank you. Kevin, I can see you've got your hand up as well.
Yeah, it was just extending the comments that were made in terms of the cost pressures. So where we sit within the supply chain, we're an M&E contractor who have demands made on us by main contractors to implement offsite manufacturing, prefabricated products. But quite often we are procured too late and decisions have already been made. The timing of some of those decisions may limit our ability to implement offsite solutions that could have benefits to program or de-risk the project from a health and safety perspective or quality perspective. So that cost time pressure is really very real. There's also a perception in some quarters that taking the offsite route, modern methods of construction is potentially adding cost. So there's a counter challenge there to say, well, we are now introducing additional steel work, additional transportation to get products to site and installed into buildings. But there's very little attention paid to some of the savings and benefits in terms of reduced labour, reduced materials, reduced wastage, and so on. And it's hard to sort of put through some of the conflict there from the different stakeholders.
Really interesting. Okay, that's great, and thank you. And I think we'll be touching on that again very much in a second. And Roy, I can see you've got your hand up, and so we'll hear from you, Roy, and then we'll skip on to the next part in the interest of time. Thanks.
Yeah, thanks, Nick. We're a client, so we're Scottish Water, and we obviously contract works out, and we have got off-site manufacturing for a transportable treatment unit. So basically a water treatment that's contained within something similar to a porta cabin, delivered off-site and then delivered to site. Because that is now a standard product, we had an example last year whereby it was getting made in the factory. That is a standard product. There was a need identified for a different site to have it brought to site as a priority over the one it was actually being constructed for. So it allowed us to lift and shift that to a differing site where increased sort of time pressure on it, and that delivered cost benefits to Scottish Water and to the supplier as well.
Wow, interesting. Okay, so a really almost unexpected but huge potential benefit there.
Definitely. Yeah.
Great, thank you. Well, that all ties in really, really nicely with what I wanted to touch on next, which is just to have a think about project life cycles. And I think we've already spoken about this, and Tom definitely explained the sort of client relationship, team building from the flow bridge. But if we think about a traditional construction project, we tend to think simplistically that you have a client who probably goes to planners, architects, who then it will trickle down the cascade with a consultant and designers. Eventually, then you'll have a contractor, a principal contractor, and subcontractors who do the construction. And at the end of that chain, you've got operatives doing the building work. What I want to sort of open the can on is, how does that model fit when we're looking at modern methods of construction? And I might come to Cliff actually, because I know you've got experience in this. And maybe if you've got any thoughts on our normal waterfall model for a project life cycle, how it applies.
Well, the situation, I think, I'm talking mostly about modular, which is where a lot of my experience is that you need to get the supplier of the modules involved really at the same stage as the architect, if you're going to get any sort of benefit out of going down the off-site route. So, it's someone who doesn't necessarily appear in that normal course of events until probably after the contractor's appointed. You start to see suppliers and you know, the other members of the supply chain. But with modular, they just have to be involved earlier. Otherwise, you can't design the building if you don't know the system, if you don't know the modular system.
Okay, fascinating. So it looks like
just on that, if you go to the 5 or 6 different modular manufacturers, they all have a different system. So you have to pick the right one early.
So that sounds like it ties in with what Tom was saying, that it was only by having the team set from the beginning and being trusted that it unlocked your ability to do this. Is that okay? Which is interesting when you're talking about competitive tendering and all of the other good stuff that we know about. Kevin, I can see you've got your hand up. Hi, Kevin. You there?
Is that a left hand up?
Might be a legacy hand. That's okay. Well, we'll move on. And so we've just had a look at the the normal project life cycle that we're familiar with, and then anyone who's worked on buildings probably familiar with the Reba stages. And they set out very clearly, you know, at the beginning, you have your strategic definition, thinking about what you want and preparing a brief, which is probably a lot of cost planning, feasibility, and then you work through the concept, detailed technical design, and then you get into construction, handover, and in use. So again, I'm interested on your thoughts as to, do those stages apply when we're talking about modern methods of construction? Maybe any architects on the call, I'd be interested to hear. You know, do you think that it's just a case of learning to adapt this, or is it something more fundamental? I might be mean and pounce on Liz, because I know you're an architect. I certainly work for an architect, Liz. Any thoughts? We've got Audley. Do you want to jump in?
Hear me? Hear me?
Oh, hello.
You're very quiet.
Okay, well, if you do want to jump in, unmute and give us a shout. So what we will move on to now is we've identified that things are different when we do modular or when we do off-site manufacture. And one of the key things that the Get It Right initiative focuses on is interfaces, because we know that it's when you have interfaces that you often get errors. And what we talk about in a lot of our interfaces training, aimed at architects and consultants and other people who work across disciplines, is we talk about the interfaces triangle. Now, most people who work in construction will be very aware of physical interfaces, you know, where a pipe hits a beam, or where your foundation goes through a sewage pipe, or where your window frame hits the wall. You know, we have physical interfaces all over the place, and we know that they need managing and they are a challenge. But we have other types of interface too. We have interfaces between people and organizations. And we also have interfaces in terms of time. So what happens before what, whether that is in terms of decisions in design, this is decided before this, or in physical construction, we do this bit of work before we do this bit of work. Now, the powerful thing with the interfaces triangle is it gives us the ability to spot interfaces that we might otherwise not notice. And the key thing is, if we ever spot one of these types of interface, say a physical interface, then there will invariably be the other types of interface too. There will be different people involved, or there will be a particular order in which things need to happen. So the power of the interfaces triangle is we can use it to spot interfaces. And we've only got any chance of managing interfaces and preventing error if we can spot them in the first place. So what we're going to do now is we're going to put you into breakout rooms, and I think we are fairly tight for time, but we'll stick with the 8 minutes per breakout group. And when you come into the breakout groups, please navigate to this area here. I'll grab you all as well so that you're all pointing in the right direction on the mural board. Here we go. There you are. And what I'd like you to do, please, is in your groups, have a discussion. You'll have 8 minutes to think, what are the new interfaces? So here's the question. There are many complex interfaces on any construction project. When using off-site fabrication or modern methods of construction, what new interfaces may be introduced? And so that's where you can use that interfaces triangle of space, time, and people to consider. Please, in your groups, put sticky notes on here, as you've done before, and pick one person from your group who's able to talk at the end. We won't be able to hear from everybody, but just have one person nominated who's able to talk about what your group come up with. So we'll put you into breakout groups now. Please come to your groups area, and in your breakout groups, try and discuss that and come up with some sticky notes that capture your thoughts. Any questions before you disappear? Great. Okay, well, in that case, I will see you in 8 minutes. Welcome back. I think you've all come crashing unceremoniously back into the main breakout or the main group. I saw lots of exciting activity, Post-it notes flying all around the screen there, so that's great. What I'll do is I will share my screen. So that means if you're in WebEx, we'll all be looking at the same thing. And I'll ask each of the groups just to give a probably no more than 30-second explanation of what are the key things you thought. Let's go to group 6 first. So can I hear from someone in group 6, please? What were your key new interfaces that you considered? We've got a volunteer.
Okay. Thank you very much. Thank you. We discussed the time frame changes, timing of deliveries, transportation as well, joints installing, foundation preparing, and planning, space planning. If not coordinated, it would create a bigger problem, and experienced human resources.
Interesting. Okay. Yeah. So there's a human side to all of this. Interesting. Great. Thank you. Let's go to group 5. What did you think? What were your main interfaces that you considered? I'll just zoom in. Here we go. We have a volunteer from group 5, please. Give you a couple more seconds. Anyone from group 5?
We've got a few people who've lost audio, I think. So some people are leaving and then coming back in. We've got a couple of people who've done that.
Nick, apologies, it's Roy. I missed your question, but I'm in group 5 and I just dialed out and back in there.
Oh, okay. Great. Oh, didn't realise we were having so many technical problems. Do you want to go, Roy, and just quickly cover what you thought in your group?
We just quickly went through around a few issues or opportunities as well, Nick. So the digital interface came out as quite a big one in terms of it's a different environment we're all operating in now virtually, and a lot of the time you assume that it will be easy to transfer documents, to transfer processes, speak about different systems, but the client system and the contractor system don't always overlap or allow that ability to cross-work in a most effective manner.
Interesting. Okay, great. Thank you. I'll be interested to see if anyone else has got the same sort of considerations. Let's go to group 4 then, please, and can hear what group 4 were thinking in terms of the interfaces you identified.
Yeah. Hi, Nick. Can you hear me okay?
I can, yes. Great.
Sorry, we got cut off, so we didn't agree who was going to chat, but I've unmuted quick enough. So.
Oh, thanks for making it back in. Thanks for fighting through. Yes.
Yeah, I think we had a chat around. There was a bit of mixed experience in the group, but probably a couple of things was that the building footprint in the area, you need to do some modular erection, maybe more because of the size of the craneage potentially that might be required. One of the members of the group had a chat about the the difference in terms of inspections and how that is carried out. So actually being into a factory and a factory acceptance rather than the traditional going to have a look at the drainage, for example, on site. It all has to be done in a sort of modular fashion in the factory. And I think probably touched on it a few of the other guys. It's just really just around the logistics. We talked about, for example, you are very much relying on a right-in-time delivery or just-in-time delivery, where potentially if one of these elements is missing or is damaged, then that can have a big impact on your overall kind of program in that modular fashion. So there needs to be a lot closer focus on that kind of logistics planning.
Interesting. Yeah, it's funny, isn't it? Because there seem to be themes popping up here that make this sound more and more like making a car on a production line than it does to what we're all used to in traditional construction. So certainly that digital, how do you get different people, different machines to speak to each other? Where do your inspections take place? So a completely different way of thinking by the sounds of it. Really interesting. Thank you. Yeah. Let's hear from group 3. Anything you want to add from group 3? Anything particular that you thought?
I think we came from 2 different levels. One was quite high and early in the design process, how the client, the designer and the supplier link in together and interface at an early enough stage to make design real, I guess. And then we jumped more towards construction and thinking about sort of how water tightness of a building would change from a sort of traditional route to having modules coming on site that aren't necessarily watertight but needing to be put in place before they can then be waterproofed. And I think similarly with someone else, then that links in with sort of just-in-time delivery of large elements that need to go straight in on site as soon as they arrive, and how that works in with the other trades doing sort of alongside maybe more traditional type stuff as well.
Interesting. Okay, so it sounds like you're identifying that it's not binary, that a construction project is either modular, modern methods of construction, or traditional, but actually we're probably in a sort of grey area of overlap. Is that what you're talking about there?
Yeah, I think so, and how those 2 things can marry in together and work efficiently and effectively, and not have one impact negatively on the other.
And that's really interesting, isn't it? Because if we're sort of talking about interfaces, well, that is a blooming massive interface. If we're saying we've got modular interfacing with traditional construction, we've got all of them. We've got the physical, we've got the people, we've got the time. You've got it all going on right there, haven't you?
Yeah.
Really interesting. Thank you. Group 2. I know you haven't got any post-its, but I'm sure you had some interesting discussion. Anyone from group 2 want to just sum up what you were discussing?
Yeah, Nick, we were discussing, Tom was in the group, and we were talking about the issue of one team developing the system and the prototype, and another team out on site putting it together once it's been prototyped and manufactured and taken out. So you need to think carefully about how to get that handover and make sure that everyone's ready for it.
Interesting.
The client needs to be on board. You know, traditionally the client has tended to sit back, but actually on the bridge, one of the key things Ahmed and Tom were saying was how it was a no blame culture, and the client was totally up for, we're going to do this differently because we want it to work, and very supportive of it. And one of the key issues again on that one was that if you've not got a site and a site team to bounce things off, particularly in terms of specifics of for in readiness for going to site, then that can be a challenge. So you need to think about how you're going to cope with that.
Really interesting. Okay. And what's so fascinating there, I think, is that a lot of what you're talking about in terms of no blame culture, able to communicate with each other, handing over information from one group to another, sounds exactly like what we do in all of the GIRI training. You know, we focus on those things a lot. So it's interesting that there are differences, but some of the underlying skills that we're identifying as key to preventing error might be very similar. Brilliant, thank you. Really interesting. And let's hear from Group 1. What did you find, please?
I'll talk for the group, if you can hear me.
Thanks. Yeah. Hi, Andy.
Hi there. It's very much again learning from the flow bridge that it's you're bringing the site tolerances and everything into the early design process with that off-site manufacture. Whereas normally on site, you'd allow tolerances as you'd build things and going along, you'd have adaptability and flexibility. You don't have that to the same degree. So whether your off-site manufacturer builds in that tolerances to allow for that, or you get better control up front to reduce the need for that variability on site, was very much where we were going. It brings things forward, doesn't it? So you're de-risking on site and you have to do your quality control really early on.
Really interesting. So listening to that, something that strikes me is it sounds like we've got a duality going on. It sounds like modular is maybe reducing the opportunity for things to go wrong on site, but hand in hand, you're reducing the opportunity to put it right on site. So that's definitely a double-edged sword by the sounds of things, isn't it? Fascinating. Thank you. Okay, that was really interesting, and particularly to see that there were different streams of thought in each of the groups, but it sounds like everyone was pretty much agreeing. Well, we're racing towards the end, so what I'd like to do is sort of dive now into our final question, and what we'll do is we'll use the chat box on WebEx to capture thought. But the question is, what do you think should be our priorities now when working on modern methods of construction to prevent error? So if everyone takes 1 minute just to think and just try and think of one priority, what would be your recommended priority in order to prevent errors when you're adopting modular or offsite or modern methods of construction? So I'll set the timer for 1 minute. Here we go. And then after 1 minute, we'll have a fastest finger competition and everyone can type their answers in the chat box and then we'll explore what you've all come up with independently. So remember, we're just going to type them into the chat box on WebEx. So we'll use this user interface here. So you don't need to type them onto the mural board. But if you know what you want to say, please start typing now in that chat box. Okay, I'll just give everyone 30 seconds more to type and then we'll start reviewing what people have come up with. Okay, so let's see what people are coming up with then in the chat box, and we'll copy those onto the mural board so we can share them later. But we've got Roy there said standardization with the ability to innovate. Have we got another comment like that? We've got redesign project controls from bid stage through to handover. James, can I ask you to just expand on that, please? What do you mean by that?
Yeah, so I've got previous experience of modular off-site build with things like bathroom pods, M&E units, cladding, and various other bits and bobs from different factory environments. And what I found from personal experience is that the process from bid all the way through to handover needs to be quite different than the standard methods we have today. So each stage needs to be carefully thought through and tailored towards off-site manufacturing. Because I'll give you an example. One of the big things I found on my previous project was that our construction managers didn't have the ability to do factory acceptance testing of bathroom pods. And so I ended up writing FAT documents and going out to Germany and training the construction managers how to do an FAT because they'd never done one before. So I think we're looking going back to your interface, as you've said before about space, people, and time, I think it impacts all of those. You've got to think about those three things when you're designing your project controls and that process.
Interesting. Okay, and that certainly sounds like you can't just bolt on a bit of modular construction in amongst your normal way of doing things. Really interesting. Thank you.
Exactly. Yeah.
And we've got Kevin. You mentioned about common communication protocols, so I presume that's. Do you want to expand on that? Is that purely a digital thing, or do you see it as something wider than that?
I think there's a digital element to it, very much so. And it was something we touched on in the group, just in terms of utilisation of digital technologies to overlay and to actually ensure that, you know, we're not only using clash detection but using other sort of opportunities to identify error and minimise the impact of interfaces between the different trades. So there's a digital element, but there's also, I suppose, there's an element that it relies on understanding what the other parties may need to know about your offsite element. So whether it's about logistics or, you know, how do we bring this product to site, deliver it, integrate it within the building? Are there any additional sort of implications because we're now bringing a larger assembled unit, whether it's, you know, on a construction element or an M&E element? The transportation and logistics requirements may be different, so there are multiple layers of communication that I think we need to consider.
Really interesting, thank you. And Sarah Marshall, I can see you've said earlier engagement between design construction teams to ensure that the design is realistic for construction. Could I ask you just to expand on that and any examples of where that thought comes from?
Yeah, sure. So I work in Scottish Water along with Roy, who spoke earlier. So one example that popped into my head, it's a really simple wee thing, but we had some works being undertaken on one of our sites, and there was a gantry walkway that was put in place with obviously railings round about it, but there was no consideration given to that one side of the railings should have had a gate on it because the site operatives had to access it to clear out a piece of kit that was on the other side of it. So I was just thinking that if the earlier discussions were held with the design teams and the construction people who have probably got a bit more experience with the actual lay of the land, especially in Scottish Water at our sites, it could potentially cut out, you know, some of these issues that come to light kind of when works start on site.
Really interesting. And it's an interesting thought with what you've just explained there is that in traditional construction, you could maybe muddle through and you'd get on site and go, actually, we'll just put a gate here, we'll just do this, we'll just do that, we'll adapt. But it sounds like you lose the ability to do that. So yeah, it's pushing all of those decisions up to the front. Fascinating, thank you. And there's a gold mine of ideas in that chat box there, so we'll copy those out. But what I'll do now is I will hand back to Cliff, who I'm sure will sum up everything succinctly in about 3 words and sort out all these problems for us. So I'll hand back to you. Thanks, Cliff.
Thank you very much, Nick. I've been interested in this whole concept of off-site manufacture and modular construction for some years, and I believe the word panacea probably doesn't apply unless there's a lot more thinking done yet. It sort of seems to be acknowledged that off-site manufacture gives you better quality. Well, it's probably in a general sense maybe true, but there are a lot of risks that need to be addressed if that's going to work. I'd like to stress that Nick was right about our training. As I was listening to all the views that are being expressed, and I'm thinking about in the background about GIRI and how GIRI's helping with this, is that our training is just as relevant in either the traditional or the off-site sense. The other thing that sprung out again is this lowest cost procurement. If you're just driving for the lowest cost and trying to get the maximum number of quotes in to get the minimum price, then it's very difficult to apply that completely in the off-site environment. You need to get earlier contractor and supplier involvement. But hey, isn't that what everybody's been saying about traditional construction as well? So, you know, the same rules apply, but just in a slightly different context, because if you don't do that with off-site construction, you can get yourself into real difficulties later. And once we're on site, the logistics are different with off-site manufacture. You've got to think the thing through. How are you going to get your toilet pods through the building? How are they going to hook up to whatever's been there, put there in for them? I mean, one example we had was the toilet pod arrives with the water supply pipe sticking out of the side, and the water supply and the building was some distance away, and so there's lots of coordination issues. But I think what we've learned is we can use our thinking about avoiding error and apply it just as much to off-site manufacturing as we can to traditional, with benefits for all. So thanks for everybody's contribution today. It's been really interesting for me, and I hope for you. And if you're members, hopefully we'll see you on Thursday. And if you're not, please sign up. I'll leave it there. Thanks very much.